Welcome everybody. In this particular lesson we will learn everything pertaining to circle theorems. Now this particular lesson can be used by students starting from grade 8 onwards to advanced GCSE, and also for anyone who is aspiring to give competitive exams like GRE and CAT. And not only that, it also greatly improves your chances of answering questions. Now these days even software companies are adopting questions of this magnitude. So without any further ado, let me just start off with the first and foremost thing is drawing a circle. Now I don't have a perfect round shaped object which I can utilize to draw a circle, so I'm using this this particular tool. I hope I'm able to get a circle. Okay, so this is a circle. Now what is the most important part in a circle is the fact that it is basically a round in nature. Let me define it. A circle is a round, this is the most important word, and followed by that it's a plane figure. Plane figures, and it has a fixed point at the center. It has a fixed point at the center. This is the next important information. It has a fixed point at the center, that's critical, and a boundary, right, called as the circumference. Okay, the spelling is critical, right? CARCUMFERENCE, and a boundary called as the circumference, consisting of points that are equidistant, equidistant, equidistant from the fixed point at the center, from the fixed point at the center. So this is the first foremost definition or understanding you need about the circle. So having given you this definition, let's move on in understanding other terminologies. Okay, the next important part or point you need to know is what is called as the line that connects the fixed point to any point on the boundary, and that is called as a radius. So this is called as a radius. So what is a radius? A radius is nothing but a straight line that connects the fixed point to any point on the boundary or on the circumference. So you can have a radius like this, you can have a radius like this, you can have a radius like this. So there is no limit for the number of radius you can draw. So this is called as a radius. So people usually represent it as R, and the plural form of radius, okay, the plural form of radius is called as radii. Now if you were to extend it, or if you were to join the center with the corresponding point that you see here, then you have one single straight line, right? So let me draw that point. Now what do you call that? That is called as the now this is the center. The center is usually represented as O. Now you got a single straight line. Now what do you call that single straight line? Now that single straight line is called as the diameter. Now what is the formula for diameter? Diameter is nothing but 2 times R, which is nothing but 2 times radius. This is the formula of or formula for diameter. Now I have introduced the term circumference, right? Now the all important question comes, what is the formula of circumference? Now the circumference has a formula. Now what is the formula? The circumference formula is given as capital C is equal to 2 times pi times r. R is the radius and pi is taken as a value of 3.14. Right? So with regard to the units in place, of course we are not making or performing any calculation. So C is equal to 2 pi r is enough. Next, we are interested in the space occupied by this circumference, or usually we call it as the area of the circle. We call it as area of the circle. So these are all standards you have to know. Now it is given as pi times r squared, square units. Okay, so this is mentioned or represented as capital A. So I have given you two formulae. C is equal to 2 pi r and A is equal to pi r squared. Right, so let us move on. The next important terminology you need to know is chord. Okay, now usually the diameter is considered as the longest chord. Okay, so what is a chord? A chord is nothing but a straight line joining joining 2 points on a circle. 2 points on a circle, right? A straight line joining 2 points, that is the loosely formed definition. So the diameter is the longest chord. So for example, you have a point A or you have a point B here and you're connecting these 2 points. That would be a chord and that is the longest chord. So in other words, there are many chords you can draw. So for example, if you were to draw a chord like this, say PQ, this is a chord. Anything below the diameter will also be chords. So you can draw innumerable chords, and above the diameter you can draw innumerable number of chords. So that is another important point you will have to know. Now I've given you point number 1, point number, of course this definition itself is a point. So I can start it as number 1, number 2, and number 3 and number 4. Now the next important terminologies you have to know is perpendicular bisector, right? So usually they will call it as the perpendicular bisector, and they would say draw a perpendicular bisector to the chord, say SP. Okay, now you have a chord like this. Say for example, let me just represent this chord as SP. This is S, this is P, this is the chord. Now they are asking you to draw a perpendicular bisector to the chord SP. Now remember, whenever they use the word bisector, it means you divide the given line into 2 equal parts. So that is the most important point you have to know. So if they're asking you to draw a perpendicular bisector, so there are 2 terms here, perpendicular and bisector. So I've just explained to you, when you have a term called bi, it means dividing a line into 2 equal parts. Now perpendicular means the divider which you are aiming to use to divide, say for example this line AB, something like that. That line which you are going to be using to divide this line AB should be dividing it exactly at the center, and that division should take place at 90 degrees. So that means what? Say for example, if someone were to ask me or tell me to draw a perpendicular bisector to the chord SP, they are telling me to divide the chord. That's the first part. The next thing is that that division should take place in such a manner that the divider should hit the chord at 90 degrees. So this angle should be 90 degrees. That's the most important part, and that's why we call it as perpendicular. So when 2 lines are perpendicular, their point of intersection is 90 degrees. So that's a very important point you have to know. So this is the next knowledge point, that is perpendicular bisector, and we will move on. Okay, knowledge point number 6. This is the question. Inscribe triangle ABC inside semicircle and find the angle B. Now this is a very loose question because there aren't any values given, but apparently values aren't given to the ignorant person, but to the knowledgeable person a lot of information is there. So what are those information? So first they are asking us to draw a semicircle. So I'm using this spot and this spot to draw a semicircle. Now what is semicircle? That's the next knowledge point you need to know. Semicircle is nothing but half of a circle, and two semicircles makes up a circle. So this is a semicircle that I have drawn here, right? So let me connect this, right? So this center, this is O, and they're asking us to draw a triangle inside. So inscribe means to draw. Now let me inscribe a triangle. So I have a point here. Let me take this particular point as B, and I'm hitting this point. From here I'm hitting this point, right? This point is A, this point is B, this point is C. AC is the diameter, right? But the triangle has one of its vertex B on the circumference. Of course, A and C are also vertices of this particular triangle. But the only thing is that this A and C are the diameter for this particular circle, O, right? Now the question here is, it wants us to find the value or the angle B. Now pause the video and think for a minute and let me know what is the value or what is this angle B. Can you guess? Yes, you have guessed it right. The value or the angle B is 90 degrees. Now this angle is 90 degrees. Now this is no magic or no fluke. Apparently whenever you draw a triangle, now I have drawn a triangle like this. Suppose you had to draw a triangle like this, right? And then connect it like this. Right? This would still be 90 degree, right? So that is the power of the circle. And this is a very important knowledge point which will be greatly asked in competitive exams or in any interviews for the matter. This is an interview question. I'm going to give you an example later on. How is this an interview question? In fact, many of the high school or senior secondary schools, they ask this question. And I will give you an illustration as we move on. So this is point number 6. Let's move on to point number 7. Now point number 7, knowledge point number 7 is tangents. Now what are tangents? Tangent or tangents is nothing but a straight line that touches the circle exactly at one point. Now if I were to be drawing a tangent, say imagine I want to draw a tangent here, right? So there is a hit at one point. So let this point be the place where the tangent is touching the circle, right? So this is the point P, right? So, and this is R and T. So if I were to represent this, I can state here that RT is the tangent to the circle O. Right? The point of contact is actually happening at P. With point of contact, you can, if you want, you can state it. That's nice. With point of contact at P, right? Okay, so having got the tangent, now there is a connection between the radius and the tangent. How am I? This is knowledge point number 8. The relationship between the tangent to a circle and a radius. So let's see that. Now question, find the angle between the radius and the tangent RT. So this is a question. So what are they asking us? They're asking us, what if there is a radius? Imagine this is a scenario, right? This is a scenario and they want us to get this angle. There is an angle here, right? So what is an angle? So what is the angle at P? And you have this question. There is a radius and a tangent meeting at a point, right? The radius doesn't go outside the circumference. The radius is hitting a point on the circumference, and that particular point is touched by the tangent. So there is a connection taking place there. Now the question is, what is the angle P? And the answer is the angle at P is 90 degrees. Remember, the radius and the tangent to the circle will always meet at 90 degrees, no matter whether they are drawn like this or for that matter in any position or any directions on the circle. Whenever you draw a tangent, I already mentioned to you, a tangent is a straight line that touches a point on the circle, and if you were to draw a radius to that particular point, the angle between the radius and the tangent will always be 90 degrees. This is a very important concept. Now, why is this a very important concept? Now, suppose there is a question. Imagine they give you this. They give you a scenario like this. So let me draw that particular scenario. Right? There is a tangent that is touching the circle at this particular point, say C, and it is perpendicular to the tangent RT. So this is a scenario, and somewhere on this particular part they have given you say 2 units. So that means the length of OP is 2 units, right? Of course the figure is little bit disoriented, so please bear with me for that. Now as I mentioned to you, point number 9, they have given us, say point number 9, they have given us SU is a tangent, right? SU is perpendicular to RT and is a tangent. Now there is a part of a radius that is intersecting the tangent. Are you observing it here? There's a part of a radius OC is actually meeting the tangent at the point C. So that would mean there is a 90 degree here, and already we have mentioned here, it's mentioned in the question, SU is perpendicular to RT. So that would mean this is 90, right? This is already 90. This is 90, this is 90, this is 90, and we know this is 90. So what is this? For sure, this is a square. Now, in a square, they are asking us to find, they have not told us it's a square, they have just asked us, find the area, right? They have given us find the area, and probably they would have shaded. There is a shade there. They say that find the area of the shaded region. We do not know it is a square, but from the information, we are putting the information together. We are drawing the tangent 1, RT, we are drawing the tangent SU, and we are connecting it with the radius OP. And then over here, the connection is already stated here. There is a connection of the radius OS at the point C. Okay. Now clearly we can see there is a 90 here, 90 here, 90 here, 90 here, and it is resulting in a square. So since it is a square, clearly this is 2 units, this is 2 units, this is 2 units, this is 2 units. So what is the area of the square? Area of the square is nothing but side multiplied into side. So 2 multiplied into 2 is equal to 4 square units. That's it. Story done. So whether it is competitive exams or interview exams or interview questions would be like this to test you, right? So this is in fact a beautiful question I have just formed here, and we were able to achieve this. How we were able to achieve this? Based on the concepts we have just studied on circle theorem. So circles is powerful objects, are powerful concepts, and we will continue our study. So we have just finished 8 points, and we will move on to actually do the research and get the other important points. So let's move on. Now the next important concept we are to know is what is called as the central angle and inscribed angle. Now what is the central angle? It is nothing but an angle formed by 2 radii inside a circle. That's critical. Of course, when we talk about radii, circle comes into picture. So let me show you the pictorial representation of the central angle. So okay, so we got a good circle, and this is the center. So as I mentioned to you, from the center we drop a straight line touching a point on the circumference. So this is a radii, and then we drop another line from the center. Now you see this is called as a central angle. This angle created by the radius, I'll just call it as R. So these two create this angle. So that angle is called as a central angle. Now coming to the inscribed angle. So let's see how the inscribed angle looks. So let me create that also. Okay, the circle is created. Now this angle is created when one of it's actually 2 chords, right, creating an inscribed angle. In such a way, I draw a chord here. Okay, this is a chord here, that's fine, and then I draw another chord from here. So you all know the definition of chord is nothing but a straight line connecting 2 points on the circumference. So this is a chord, right? So this can be named as PQ. PQ is a chord, and RQ is also a chord, right? So there is a vertex on the circumference. So that is the catch point here, and there is an angle that is created, and this, of course, there is a center for our circle, and this is called an inscribed angle. So most of the times there will be a composition of central angle and inscribed angle in the questions asked. So it becomes imperative first to get an understanding of these concepts, what a central angle is and what an inscribed angle is. Now let's move on to point number 10. Now this is 9 and this is 10. So in this you will have to understand the meaning of subtend and arc, right? So when exactly you will come across this term. So what exactly is the meaning of to subtend an arc? It is nothing but an arc is created. Let me just start off like this. An arc is created by two straight lines that joins, or you can use the word touch. I think I will just stay with join. End points of the arc. So in this case, if you were to see, there is an arc that is being subtended. Now if you were to take this line as say OT and this Q, OT and OQ, they are creating an arc. This is the arc that is being created. Okay. So whenever you say arc, the most important formula comes into place, and that is called as arc length. So when we talk about arc length, we are talking about the length of this arc TQ. Now it has got a formula. So arc length is given by this formula, theta over 360 multiplied with 2 times pi and r. So there is a theta here, and that is this theta which is present here. Now what do you call this? That is the knowledge point number 12. It's called as subtended angle. Subtended angle. So I've already mentioned to you subtended arc. Now this is called a subtended angle. Now what is exactly an subtended angle, right? So that is a very important concept that you will got to know. So let me write the definition for subtended angle. It is the angle created, right? That's an important word, between two straight lines that joins the end point of the arc. So in this case, two straight lines OT and OQ are creating this theta between them, and what exactly these lines do? They are basically joining the end points of the arc. So that is the understanding of subtended angle. Now what we can do is, after understanding this, probably we can do a problem on subtended angle just to get a clear understanding. Remember, this is the formula to calculate the arc length. So to recap and reiterate, in this particular section we have come across, or we have studied, the following important concepts. One being subtended arc, length of the arc, and then subtended angle. And we move on. Now to do any question, we need a very important result, and I'm going to show you that result now. So let me just connect the point P with the center. Let me name the center as O, and also the point R with O. So there is a central angle that is being created, right? Now there is a question. Say we have been given, say if this is 45 degrees, and we are expected to find the angle POR. So this is required, right? Now there is a very important result you should know. What is that? Angle POR is equal to twice the angle PQR. Very important. This will be used in, or used for many applications, right? So have that in mind. So with that, we've been given PQR. What is that PQR? PQR is 45 degrees. and 2 times 45 is going to be 90 degrees. So therefore POR is 90 degrees. So this is a 90 degree angle. So that is a beautiful question. So this can be taken as concept number 13. So we not only studied how to handle this question, but also an all important result. So we'll move on to the next one. Let's do this interesting question. Let me draw the circle first. Okay. Now we have an inscribed angle. So the moment I say inscribed angle, it would be somewhere over here. So let me just take that point over there and let me have it as P and a point over here, say Q and R. So let me join these points, and of course the center, all important center O. So we are joining the points. Okay, now we are expected to find the following. So let me give this as 30 degrees, and we are asked to find the arc length, right? So this is a key feature. We have to get the length of the arc. So calculate QR, arc length. Okay. Now we are also being given this information. The area of the circle is 9 pi square units. This is given. Okay. So now let me subtend a central angle, right? Because it talks about arc length, so I'm subtending a central angle because I need to get the value of theta. So central angle is subtended, so this is going to be theta. Now there is a formula for arc length. So what is that? Arc length is equal to theta over 360 multiplied with 2 times pi times r. So we need to get the value of r. We don't know. Now what is theta? Now theta, what is theta? If this is q, it's given as q o r is equal to, what's the formula? It's 2 times angle QPR, right? So this is equal to 2 times R. What is QPR? 30, 2 times 30 is 60 degrees. So I've got theta. So arc length from here is equal to 60 divided by 360 multiplied with 2 times pi times R. So if we were to cancel 0 and 0, 6 divides 36 6 times, 2 divides 6 3 times. So this is equal to pi r divided by 3. But we need to get the value of r. So area is given as 9 pi. Right, so let's use it. We know that WKT stands for we know that the area of the circle is pi r squared. So if we take this as 1, right, so this would mean using 1 we get, so what do we get if we were to use 1? Pi r squared is equal to 9 times pi. I can cancel the pi, so I would get r squared is equal to 9. Therefore we are dealing only with positive quantity when we apply the square root function. So r is equal to root of 9, which is equal to 3. So r is equal to 3. If I were to take this as 2, so therefore arc length is equal to pi times 2 it's 3 actually, not 2. 3 divided by 3, right? So 3 gets cancelled. So we are getting pi. So length of the arc is pi. And since we're dealing with length, it's pi units. Point number 14. Point number 14 is this. Angles drawn in the same segment remains the same, right? So imagine I have a central angle drawn like this, and this angle is given to be as a 120 degrees, and suppose I have an inscribed angle somewhere over here. And it is connected right like this, and you are asked to find alpha. Find alpha. That's the requirement. So what is alpha? Can you take a guess, or can you get the value of alpha from the information that I have shared with you? Of course, alpha will be 60 degrees because of the fact the inscribed angle is half the central angle. Central angle is 120, and so alpha is going to be 60 degree. Now the question comes here is, what if I were to move the angle from here to over here? What would the value of alpha be? That's an all important question, right? Now suppose if I were to move this point from here to here, and I am connecting it, say let me consider this point here, and I'm moving this point from here to here, right? And it is connected to this particular point here. So my question is, let me call this as beta. What would be the value of beta? Of course, you're correct. Beta will also be 60. So no matter where the point moves for the inscribed angle, angles drawn in the same segment, so they should be lying in the same segment of the central angle, they will always remain the same. So no matter you're taking it here or here or over here or over here, it doesn't matter. The value will always remain 60 degrees because of the fact the central angle is 120. But the moment they change the direction, instead of moving over here, if they were to move on this side, the angles would be different. So I have that point. So this is a very, very important property of angles. Okay, so now it's exercise time. I want to give you a few questions. Alright, so this is given to be as x, this is given to be as y, and this is given to be as 57 degrees. You're asked to find what is the value of x along with the value of y, and this is 57 degrees. The answer is 57 degrees. Why? As I mentioned to you, angles drawn in the same segment remain same, or you can replace that word same as equal. Right, so this is actually, if you're taking this point as P and this point as Q, all of these angles which you see here, they are on the same side of the central angles because the positions are not changing, the direction is not changing. So x will be 57, y will be 57. Okay, we got another question. We are expected to find the value of A and the value of B. Now clearly we will be using the same property. Angles drawn in the same segment remains equal. So angle A is equal to 62 degrees and angle B will be equal to 32 degrees. So that will be the solution for this question. This is another question, students. We are expected to find the value of x and the value of y. As always, we will be using the same property. Angles drawn in the same segment remains equal. So in this case, x is 73 degrees and y is 105 degrees. So that is the solution for this question. So we'll move on to the next set of questions. Okay, we got a list of questions here. We got question 1, question 2, 3 and 4. So we are expected to find the respective angles. Now before we could start off in solving this, we would have to understand a very important theorem which I have already explained to you in the earlier class, and that is the line passing through the center is called as the diameter. The diameter is the longest chord, right? Let us consider this to be as P and Q. Now suppose from P I draw a line touching the circumference and I complete it with a straight line drawn to Q. Okay, now there is an angle that is made here. Now this angle will always be 90 degrees. So the rule is, whenever you draw a triangle such that P and Q, the diameter of the circle, happens to be their vertices, for sure the third angle should be 90 degrees. No matter where the triangle is oriented. I can have the triangle oriented in this fashion. I can even stretch it like this. So instead of drawing it like this, I can actually take a point over here and connect it to P and then connect that point to Q, and this one will still be 90 degrees, right? So that is the important rule we need to apply here. So by applying that rule, if we were to consider this, as I mentioned to you, if we were to take this point as P and this point as Q, having P and Q as the vertex is, if we were to draw a triangle is drawn, this is going to be 90 degrees. We expected to find the value of M. So if we were to add 90 plus 70, I would get 160. The total angles in a triangle is 180. So from 180 you subtract 160, you get 20 degrees. So angle M is 20 degrees. That's the answer. This is 43 degrees. I know for sure this is 90 degree. So this is going to be 90 positive 43, which is 133 degrees. So from 180, I subtract 133. So 10, 7 is going to be 4, and angle N is going to be 47 degrees. So that's a solution. So we have solved this. Coming back over here, as I mentioned to you, if I were to take this as P, I see a diameter here. This as P, this as Q. This should be 90 degrees. So we are expected to find X. So 90 added with 52 is 142. So from 180 I subtract 142. That's going to be 10,873. So angle X is 38 degrees. So that's a solution here. Now if this is P, say for example, I can't take P, P is already here. This is A, this is B. AB is the diameter. For sure this should be 90 degree, right? So from 90 degree you take away 60 degree, 63 degrees. 10, 7, this should be 27. So angle P is 27 degrees. Over here you just visualize this. This entire thing is P and Q. So this entire region is going to be 180. So from 180 I take away 132. So 10, 8, 7, 48. So this is going to be 48 degrees, right? I want to know Q. I know this is 90. So 90 added with 48 is 138. I need to know Q. So from 180 I take away 138, 10 to 42. So angle Q is 42 degrees. You see that? Just because we know this all important theorem, all of these questions can be solved in a fraction of a minute. Okay, we got a list of questions where we have a quadrilateral inscribed inside a circle. Inside a circle, right? Now what do you call this quadrilateral? Now you can clearly see all the vertices of the quadrilateral lies on the circumference of the circle. Now when this happens, we call the quadrilateral as cyclic quadrilateral, and the opposite angles of the quadrilateral add up to 180 degrees. So that is the all important property, I should say, for cyclic quadrilateral, right? So for the cyclic quadrilateral, all of these vertices, say for example you're naming the side A, B, C, D, should lie on the circumference, and the opposite angles, they add up to 180 degree. Now we are expected to find X and Y. Now X positive 84 should be equal to 180, right? So that would mean X is equal to 180 minus 84. So let's subtract 180, 84, 10, 6, 17. That's going to be 9. So X is equal to 96 degrees, right? Now Y positive 110 is equal to 180. So 180 minus 110. What is that? 180 minus 110. 0, 7, 70 degrees. So angle Y is 70 degrees, right? So in this case P positive 72 is 180. So therefore P is equal to 180 minus 72. Let me calculate that. 180, 72, 10, 8 and 0, 108. So angle P is 108 degrees, and then I'm using the space Q and 68. Q added with 68. Q added with 68 is 180. So Q is equal to 180 minus 68. So write that down. 180 minus 68. 10, 2, 7, 1. 112. So angle Q is 112 degrees. Right? Coming back or coming to this side. Opposite angles. See, for example, Y and 102. Y positive 102 is 180 degrees. So Y is equal to 180 minus 102. So what's that? 180 minus 102, 10, 8, and I bring a 7 here, so 78. So angle Y is equal to 78 degrees. Now what is X here? X is also opposite to 102. So X will also be 78 degrees. So that's a solution there. Now we are expected to find Q and P. So clearly we know P added with 2P is equal to 180. So 3P is 180. So P is 180 divided by 3. 3 divides here 60. So angle P is 60 degrees. Now over here, opposite sides add up to 180. So 2Q added with 3Q is 180. So 5Q is 180. So Q is equal to 180 over 5. 5 3s are 15. And you carry 3. So that means 36 degrees. So P is 60 degrees and Q is 36 degrees. So we have solved all of these questions. All because we know the concept, and we have done this in a fraction of a minute. Let's move on to the next question, students. We have a series of questions here, students, and in each of these questions we will be using what is called as the alternate segment theorem. Now what exactly does this theorem mean? Now we got a tangent here. Let me just show that to you. We have a tangent here. It is making a contact. Let me assume this contact to be as P. And this is the point of contact of the tangent with the circle. And there is also a chord that is coming here. Say, let me take this chord as Q. PQ is also a chord. And AB is the tangent. Now the tangent AB is hitting the circle at a point P. Chord PQ makes an angle of 70 degree with the tangent. So let me state that here. Tangent AB, let AB be the tangent to the circle such that AB makes a contact at P with the circle. Chord PQ makes an angle of 70 degrees with a tangent. Find angle P, right? So this is the statement. Now remember, the tangent is actually making an angle with the chord PQ, and the angle is 70 degree. Now this angle will directly be the same to the angle P. In other words, the angle P, which is opposite to the angle made by the tangent and the chord, will always be equal. So in other words, the angle P is going to be 70 degrees. So this is the concept of alternate segment theorem. So to requote it or to reword it would be in this way. The angle that you see here would exactly be equal to the angle opposite to the value or to the angle that you see inside the triangle, such a way that the angle that you actually see would be the angle made between the tangent and the chord. So having mentioned that, we would be utilizing this concept in solving this question. So let's go on. So we got a chord here, and there is actually an angle made by the chord BC with the tangent, say MN. So this angle will be equal to the angle that is found opposite and inside the triangle. Probably that's loosely explained, and from here clearly I can see that angle Y, because angle Y is actually lying opposite to the angle at A, which is present inside the triangle. So that would mean angle Y would be equal to 49 degrees. Now we are expected to obtain the angle X. Now angle X is actually the angle made between the tangent and the chord AC. So the angle that is found here would be directly equal to the angle that is found opposite and it is present inside the triangle. So in this case, angle X is going to be 67 degrees. Of course, this is little bit complicated to understand, but with some practice it would become easy. So that's the solution for this question. So moving on, we are expected to find angle P and angle Q, and we are given 76. As I mentioned to you, this angle would be same as the angle found inside the triangle, because given the fact that they are opposite to each other. So in this case, clearly angle P would be 70 degrees. I need to get Q. So P plus 76. So what is that? 70 plus 76, that's going to be 146. I subtract 146 from 180. So 10, 4, 7, 34. Right? So this is going to be 34 degrees. So that's the solution for question number 2. So this is 2 and question 1. So moving on. So the same concept we are utilizing, right? The alternate segment theorem, that comes in handy. So in this case, you can clearly see, if I take ST to be the tangent is making an angle of 46 degree with the chord, say PQ. Right? There is an angle that is being made by the tangent with the chord PQ, and that angle is 46. So this angle will be same as the angle inside. So that's going to be Y is equal to 46 degrees. That's fine. So I've got the value for Y, and now I need to get the value of X. Now this X and the angle inside would be one and the same, but this angle is 114, but this entire angle is going to be 180. So from 180, let me use this space. From 180, I'm subtracting 114. This is 10, and 6. From 7, I take away 1. I get 6. 66 degrees. So this is 66. If this is 66, X should also be 66. So the angle X is 66 degrees. So that's the solution. Isn't it easy? It's simple, right? That's the beauty of this alternate segment theorem. So this angle and this angle will be one and the same, and this angle will be the same as the opposite angle Y, right? So we can easily extract it from there. So clearly I can state from here, angle Y is 59. That's done. Now I can add these two together, 59 and 87, 9 and 16, 113, 146. So from 180 I subtract 146, 10, 4, 7, 34 degrees. So angle X is 34 degrees. So I've got angle Y, I got angle X, and now comes angle Z. So clearly you see this angle Z is opposite to the angle X, which is present inside the triangle. So clearly I can say Z is equal to 34. 34 degrees. You see that how simple it is. So this is a lovely theorem, mainly because just look at the diagrams. How complicated are they? Yeah, right. The very first glance really can really send stability issues whenever someone is watching these questions, right? But we solved all these questions in a fraction of a minute. Why? How is it possible? It's because of this beautiful alternate segment theorem. Thank you, students. We'll meet you all in the next class. This is concept number 15. We have done lots of questions regarding the circle and obtaining an understanding on circle theorems. Now this is another important theorem you need to know. Now we have a circle and I'm going to be connecting 2 points on the circumference in this fashion. So this is the center O and this is the radius, right? So let me name this as P and this point as Q, and let me connect P with Q. Okay, now imagine this angle is 80 degrees and they asking for the angle P and angle Q. Can you give the angle for P and angle for Q? Pause the video and then work it out. Okay, let me give you the solution. Now clearly this is a radius, right? OP is a radius and OQ is a radius. So two sides are equal here. So let me mention that. On observation, OP is equal to OQ is equal to radius. So this means two sides of the triangle POQ are equal. This would mean triangle POQ is an isosceles triangle, right? Now this means if two sides are equal, then the base angle of these sides should be equal. So this means angle P is equal to angle Q, right? Now we know that the sum of the angles in a triangle is equal to 180. So let me just state it. Since we know that WKT stands for, we know that the sum of the angles in a triangle equals 180. This would mean I can subtract 80 from 180, giving me 100. And what I'm going to do, I'm going to divide this 100 by 2 into two parts, so which is equal to 50. This in turn would mean angle P is equal to 50 degrees and angle Q is equal to 50 degrees. Isn't it amazing? All we know in this case is OP is equal to R and OQ is equal to R, because they are the radii of the circle. And from this we were able to obtain the angle for P and angle for Q. So we are going to be utilizing this concept. So just to have a reiteration of the concept that we studied, if you inscribe a triangle inside a circle in such a fashion that O, or I should say two sides of this triangle, represents the radii of the circle, then it is an isosceles triangle. And once we know one angle, right, the other angles can easily be found. And I've given you the exact working, how exactly we can find the angles in an isosceles triangle. And more so, the triangle is inscribed inside the circle. So let's do some questions, students. So we have two questions here, students. We are expected to find the value of x, and this angle is given to be a 78 degrees, and clearly you can see that there is a connectivity from O to the end point. Let me just name these points as A and B. So clearly we can see that OA is equal to OB is equal to the radius of the circle. And as I mentioned to you, once two sides are equal, so this side is going to be equal to this side. So when two sides are equal, we are dealing with an isosceles. So that would mean the base angles are also equal. So once the base angles are equal, it's easy that from 180 degrees we need to subtract 78 degrees, and that would give us 102. So 180, from 180 you subtract 78, 10, 2, 0 and 1. So you're getting 102 degrees. Now to get angle x is going to be 102 divided by 2, which is nothing but 5 and 1 degrees. So angle x is 51 degrees. So that is the solution for this question. Now over here you got I should say Q and P, or PQ. PQ is the diameter, right? This is the center. PQ is the diameter. So we have already studied a theorem. So from the diameter, I have two straight lines hitting a point on the circumference. So if this be R, definitely I know for sure this angle which we see here, this should be 90 degrees. So what I wish to do is from 90 degrees I subtract 60, I would get 30. So this part is going to be 30 degrees, right? So I've already got 30 degrees. Now I need to get angle Q. We are expected to find angle Q. Angle 60 is known, and since we have already got 60, we would be in a position to extract the other angles also. Now clearly you can see that this is the radius, this is the radius, and you got one more radius here, right, from O, and OR. So make the observation, OR is equal to OP is equal to OQ is equal to radius, right? Now clearly you can see this is a side, this is a side. So two sides are equal, so the base angle would be equal. So this is going to be 30 degrees. So from 180 you subtract 30 plus 30, 60. That's going to be 120 degrees. So this is going to be 120 degrees, and they want us to get angle P. So angle P is equal to 30 degrees, right? So now we need to obtain the angle Q. So Q is over here. So this is a radius and this is a radius. So since you can state it, OQ is equal to OR, so two sides are equal. So this means their base angles would be equal. Base angles are equal. You can clearly see that, right? So this is a side which is produced by the radius O to R, and this is a side which is again produced by the radius OQ, and two sides are equal. So the base angles located over here and over here are also going to be equal. So this is going to be equal to 60 degrees. So this would mean angle Q is 60 degrees, right? And this is in fact an equilateral triangle. 60 degrees, 60 degrees. This will also be 60 degrees, right? You can clearly see that. So that is the end of this particular question, students. I hope you enjoyed this session. Students, in this particular session, we will try to do as many as problems on circle theorems. So we got two questions here. The first question is expecting us to obtain the angle A and angle B, and we are being given that angle Q is 50 degrees, right? Now we clearly know that angle A, let me write this down, is equal to, this is a central angle, right? I can state it, since angle A is the central angle, so this would mean angle A is equal to 2 times angle Q. Why? Since angle Q is the inscribed angle, right? So therefore angle A is equal to 2 times of 50 degrees, which is equal to 100 degrees. So this is the value for angle A. Now we also need to get the angle B. Now this is a circle. A full circle is 360 degrees. So therefore angle B is equal to 360 degree. Angle A is 100 degrees. So angle B is equal to 260 degrees. So that is the solution for this beautiful question. It's a lovely question. Let's do this question, students. We are expected to find the value of C, the value in degrees. We are also expected to get the value of D in degrees, and the value for E. We need to know what is the value of E. So what I will do, I will just represent this in lowercase, right? O is the center. So the following observation, okay, we can make the following observations. So what are those observations? O is the center of the circle, and OF is equal to OH is equal to OG is equal to R, which is the radius of the circle, right? You all agree on that. Now this entire thing is 180, right? So we need to obtain, first we need to obtain what is this. So if I were to take this as some x, now x is equal to, let me just take it as some x, 180 minus 158 degrees. So what is that equal to? 180 minus 158 is going to be 10, 2, 7 and 2. So 22 degrees. So this value is first got to be as 22 degrees. Fair enough. Now since OF is equal to OH and they form the sides of a triangle, right? Sides of a triangle. I'm making the statement. So this would mean HOF, triangle HOF is an isosceles triangle, right? Two sides equal, so it's isosceles triangle. So this would mean the base angles are equal. Base angles formed are equal, right? So this would mean C is going to be equal to 22 degrees, right? So I've got, let me make that mark there. So this angle, because these two sides are equal, this is equal to this, and the base angle created by them will also be equal because of the fact that they are isosceles. So I've got the value of C. Now I need to obtain the value of D, right? To obtain the value of D, I need to get this angle. How do I get this angle? I've got 121 and I've got this C is equal to 22. So to get, first I need to get this angle. So let me do that. Okay, step 3. I will take this as step 2. Then I'll make this as step 1. Right? This entire observation. So step 3, 121 degrees added with 22, that's going to give me 3 and 4, 143. So from 180 I subtract 143. It's going to be 10, it's going to be 37 degrees. So this is going to be 37. Okay, 37 degrees. This is 37. Now clearly you can see that. Let me state that since OH is equal to OG is equal to R, and they form the sides of triangle HOG, this would mean the base angles. Before I could say base angle, this means they are dealing with an isosceles, so I don't need to write they. This would mean that angle or triangle HOG is an isosceles. Is an isosceles triangle, right? So this would mean if I were to take this as say lowercase p, some lowercase p and lowercase q, and let me write that down. P should be lowercase p should be equal to lowercase q, because of the very fact that we are dealing with the isosceles. So this in turn means q is equal to, what's the value we got? Q is equal to 37 degrees, right? But we need to know the value of D, right? So therefore my D is going to be equal to this entire angle is 180 degrees. You can clearly see this entire thing is a straight line, and we know this is 180. So D is equal to 180 degrees. From 180 you take away 37 degrees. So what do you get? 180 minus 37, 10. You get 3, 7 for 143 degrees. So this would mean the value of D is 143 degrees. So let me box these results. So I've got this result, I've got this result, I've got this result, and of course I've got that. Now we need to obtain E. We need to get this E, right? So this is actually the central angle. E is a central angle. So let me write that. This is a central angle. E is the central angle here. So that would mean E is equal to, what is that? 2 times of this angle P. I have got the value of P to be as 37 degrees, and the value of C to be as 22 degrees. So you add them, you get 9, and 2 plus 3 is 5. You multiply by 2, 9 2s are 18, 1, 5 2s are 10, 11. 118 degrees is the value of E, right? We can make a box here. So we have got all these values which are required in the question. So we'll move on to the next one. We got this question, students. We are expected to find angle B, angle A, angle C, and angle D. Now clearly we can see angle C is equal to 42 degrees, because angles created in the same segment by the chord will always be equal. So we got C, and in this case clearly we see that A is going to be equal to 83. Now this is 42, so 42 plus 83 plus B should be equal to 180. So if I were to add these two, this is going to give me 5 and 125. Positive B is equal to 180. So therefore the value of B is 180 minus 125. So it's 10, 5, 7, 5. So B is equal to 55. So I know C, I know this angle 83. So D can be obtained as, so D is equal to, from 180, I would subtract 42 plus 83. So this is going to be 5 and 125 and 180. So from 180 I need to subtract 125, and that would give me the angle D. So 10, 5, angle D is equal to 55 degrees. So angle B is 55, angle D is 55. So clearly we can see the angles created, or the angles that are lying in the same segment created by the chord, will always be equal. So this clearly ascertains the fact that B is equal to D and C is equal to this value 42, right? So that is the end of this particular question. Let's do this question, students. Can you find out the value of X? What is this value? Maybe you can pause the video for a minute and you can get the answer to this question. Okay, now I hope you all have got the solution. Now what theorem we are going to use here? The theorem we are going to use is angles coming from the same arc is always equal. Right, so this is the property we will be using. So in this case, PS is the arc we are talking about, and this PS is involved in the creation of this angle as well as this angle. So this would mean the value of X will be 43 degrees. Now let me draw your attention to the previous question. Now if I were to take this as P and S, PS is the arc that is responsible in the creation of B and creation of D. So clearly D should be equal to B, right? And also PS is responsible in the creation of S and in the creation of this angle 42. So that is why we have C to be equal to 42 and D is equal to B. So that's just a side note for your attention. So let's do another question. We got a beautiful question here, students. We've been given a circle and the following figure is inscribed inside the circle. Now this is the arc, and as I mentioned to you, angles created by the same arc will be equal. So this arc PQ is responsible in creating an angle here, and the same arc is actually responsible in creating an angle here. If you were to move this along this direction, you will result in creating an angle over here. So let's fill in the information. We've been given SPR. SPR is 44 degrees. So this is 44. And then PRQ is 60. PRQ is 60. We asked to find SQR. So we asked to find X and we are asked to find PSQ. So we are asked to find this also, right? Now clearly you can clearly see, if you were to move this point, and this point together, that would result in creating the point P and S. So the angle would not change, and since we are in the same segment, the angle would remain the same. So my Y will be equal to 60 degrees in this case. So Y will be equal to 60, and in this case, as I mentioned to you, my X will be equal to 44. So if you were to represent it in form of the given requirement, SQR, so SQR is equal to 44 degrees and PSQ is 60 degrees. So this is the solution. Now we were able to arrive at the solution in a quicker manner is because of the concepts we have already studied.